Hello, my dear friends. Welcome to BYJU'S exam prep. Very good evening, guys. Good evening, all of you. I hope everyone is good. Fine. Good evening. Good evening. Okay, all right. So today we're gonna have some practice session for the HAL examination. Basically, not only HAL. We can definitely have. One second, guys. We can definitely practice for ISRO also and HPCL also, right? Okay. So very good evening. Good evening. Let me check from my end. All good. Please do let me know in the comment section. Very good evening, Karan. Good evening. How is your preparation going on? Excited for HAL and HPCL because it's a lined up examination. We can say date is not being announced, but definitely they will be commencing in on a one stretch, like 1 or 2 weeks ka difference hoga, and we will be having a lot many examination. Good evening, Shreyas. Good evening, Kiran. Good evening, Papa. Nice name. Okay, chaliye. So before starting the session, I would like to ask you, how's your preparation going on? GATE and ESE के लिए, basically PSU examination के लिए, how's your preparation going on? All good, all perfect. GATE के लिए session बिल्कुल यार देखो, definitely हमने I've already planned like 4 PM in the app. We are having the GATE के लिए session. MSQ series I've already planned. Right, और PSU examination के लिए I planned on the YT every day at 7 PM. So that is the schedule for this week. Next week we'll be having some other schedule. So definitely we need to just connect with me on my Telegram channel where you will be getting all the updates. Okay, right. So can we begin the session? Yes. Hello. Good evening. Very good evening. कैसे हैं? अच्छा, हाउ मेनी ऑफ यू हैव कंप्लीटेड द रिवीजन वन टाइम फॉर द एंटायर सब्जेक्ट्स? पूरे सिलेबस का रिवीजन डन? हाउ मेनी स्टूडेंट्स हैव डन द रिवीजन ऑफ द एंटायर सिलेबस? एनीवन who was planning to give HAL or HPCL or ISRO examination? How many of you completed at least 50%? Let's hope so. 100% is not even possible. Okay, 50% syllabus. Okay, चलिए बहुत बढ़िया. और कोई 50% completion and your revision is still going on. Okay, let me tell you a simple trick, because before starting the session, let me tell you a simple trick. If you are planning to give ISRO, HAL and HPCL, these 3 PSUs, the level of questions is very basic. You can score a good number of, you can definitely get a very good score. Only thing you have to do is daily practice. That is the only remedy. If you have completed the syllabus, then I would dedicatedly suggest you that please try to practice every day. Wherever you are practicing, but try to practice every day, because अगर वो नहीं करेंगे then what will happen, you will be losing the touch with the subject. Every day try to mix the subject, or every day one subject you are completing, and repeat that process again and again. Okay, HCL का फॉर्म फिल नहीं हुआ परसेंट पॉइंट. अरे भाई ओहो, चलो कोई नहीं, HCL की तैयारी करें. डेफिनेटली यू कैन प्लान फॉर ISRO also, right? You can plan for HPCL also. Okay, the reason why I'm taking is HAL only. It's not only HAL. Definitely we are practicing for all the PSUs क्योंकि the level of question is same in all the different PSUs. Okay, चलिए, right? Can we proceed? अच्छा, before starting, my audio and video is all good. Please give a thumbs up. एक बार thumbs up लिख दीजिए comment section में, so that we can start off the session. And this is all about me. So you have all connected with me on my Telegram channel, that is Mechanical by Suraj, and I'll be updating the schedule of this series that I have planned for HAL, HPCL or ISRO completely every day 7 PM. What are the subjects that we'll be having every day? We'll be commencing the class at 7 PM. Okay, chaliye. You can do connect me on my Telegram channel where all the updates is being given and lot many classes is being planned. So stay updated, stay connected. So let's begin with the first question on the screen. जाने से पहले मेंस का रिजल्ट जैसे आपको पता है last month it has been out, and we have already mock interviews being planned. So those who are not yet we can say join to this, directly join that. Okay, fine. चलिए, so can we proceed? Yes or no? Okay, Sher is saying yes. What about Kiran? Everyone? Chalo, let's go with the first question on the screen. And to register for this scholarship test that is being commencing on 10th of September, the link is in the description. Okay, so first question on the screen. Very easy question. देखो, if you see HAL, HPCL, ISRO के जो questions के level है, that is very basic. Only you have to just brush up the entire syllabus. That's it. ठीक है, syllabus में कुछ छूटना नहीं चाहिए. You have to revise the entire subject. Okay, so by this series we'll be able to cover lot many questions in a less stipulated time. Okay, how many ICs are there in a mechanism with 8 binary links with 1 grounded? How many I centers are there in a mechanism with 8 binary links and 1 grounded link? 15, 21, 28, 36. 30 minutes में खत्म करना है. We have to complete the entire segment in 30 minutes. Yes. Quickly. A, B, C or D? Is it 15, 21, 28 or 36? What do you feel? What do you, what is the answer you're getting? इसमें confusion हो सकता है. You can get a small minor mistake. And HAL, HPCL in ISRO में इस type of question बहुत बार देखे गए guys. So, okay, we are having Pravalika saying C. Okay, option C. Anyone else? Anyone else? Negi? Yes, everyone. Kiran, what is the answer? Arey, just be active. For the next 30 minutes, you need to be super active because there are lot many questions. Not 10, not 15, more than 20 questions is being there. Okay. Rohit is saying option C. Okay, perfect. Anyone else? Option A, B, C or D. Acha, tell me one thing. How many number of links are there? We are having the very simple formulation. The number of I centers. Number of I center is equal to n into n minus 1 by 2. This is the formulation. Acha, what is the number of links we are having? Is it 8 or 9? Good evening, Mr. NV. Good evening. How many number of links are there? They are saying that there in the mechanism there are 8 binary links with 1 grounded link. 8 binary links hai with 1 grounded link. So how many number of links are there? 8 or 9? Arey, you have calculated 28, so might have used some value, right? Yes, yes. A, B, C or D. Even if you are taking 8, right? 8 into 7. 56 by 2, that is 28. But if I take, let us suppose if I take, they are saying that in a mechanism there are 8 binary links with one grounded. Okay, so we are having so total number of links is 9. We are having 8 binary links and we are having 1 additional grounded link. So total number of links is 9. So it will be 9 into 8 by 2, that is 36. Option D is the correct answer. Read the statement carefully. Question को ध्यान से पढ़िए. If you commit a very small minor mistake, that wrong option will be there. और ये होता है in any PSU examination because time is a very crucial thing. Less time पे you have to cover lot many questions. Okay. चलिए. Can we proceed to the next one? Question number 2 on the screen. A footstep bearing and a rotor of a vertical turbine forms an example of incompletely constrained motion, partially constrained motion, completely constrained motion, and successfully constrained motion. What do you feel will be the correct answer? A, B, C or D? Footstep bearing, remember, if you have studied the concept of relative motion in theory of motion, there we have discussed this concept. A footstep bearing or rotor में what is the type of constrained motion we are having? Incompletely, partially constrained, completely constrained or successfully constrained? We are getting some responses. It's quite easy. Very good, very good. We can say that if this is your footstep bearing, okay. So if I'm using a shaft, so if I'm only placing a shaft, it can have a rotational as well as a translatory motion, right? But due to the application of the force, when this BYJU'S example is applying a force of F on this shaft, it will be restricting this. We only have a rotational motion, and that is basically successfully constrained motion. That will be example of a successfully constrained motion. Okay, option D is a correct answer. Footstep bearing, a simple sub formulation, and this is an example of a successfully constrained. Okay, clear? Very good, very good, perfect. Next question on the screen. ये लीजिए. Which of the following statement is appropriate for a governor of an engine of which the speed continuously fluctuates above and below the mean speed? A very easy question. Which of the following statement is appropriate for the governor of an engine of which the speed continuously fluctuates up and below the mean speed? What is the type of this condition we called? CGBM का एग्जाम कैंसिल हो गया क्या? ये वो देखना पड़ेगा यार. I don't think so. Notification तो अच्छा, good number of vacancies were there. Okay, let me see. इस सेशन के बाद आप मेरे को ना कांटेक्ट कीजिए. Let me have a look on this. Stable, hunting, isochronous or unstable? Arey, very easy question, guys. I want a correct answer. What is the situation, like if you're having a condition that the governor of the engine, which the speed continuously fluctuates up and down below the mean speed, what is this condition called? Isochronous, hunting, stable or unstable? Yes, anyone else? Rohit, Kiran, Pravalika, A, B, C or D? They both are saying option C. Is it correct or not? Arey yaar, it's a very easy one. Exactly, Pravalika is absolutely correct. But this condition is called hunting. Okay. This particular condition called we call it as hunting of a governor. Hunting mein kya hota? What is happening? We are having a too high sensitive governor and the sleeve is moving up and down continuously, and due to that what happens, we are having continuous upper sleeve is moving up, ऊपर वाले portion में नीचे वाले stopper में it is continuously hitting the stoppers, and this condition we call it as hunting. इसी को बोलते हैं hunting. Okay, the sensitivity or sensitiveness of a governor is too high, not infinite. Infinite hoga, that will be isochronous. If sensitivity is infinity, then that will be isochronous. Hunting may it is very high but not infinite. Okay, clear? Option B is the correct answer. These are very small concept where the question is being framed, and definitely every year they're asking not the same question, but if you see the last years of trends, normally the question is being asked like this only. Numerical थोड़ा सा कम आता है. Okay, can we proceed now? Next question, question number 4th. अरे हाँ ना बोलो. Yes, all good. लगता है we have to have that energy booster. Energy booster चाहिए. Okay, energy booster के लिए देखो, let me give you a simple tension. देखो, if you have tension, we'll be having stress. If you're having stress, we'll be having strain. और strain होगा कहाँ? Where the strain will be occurred? In the brain. And when the stress and strain combined is occurring in the brain, तो ultimately easy concept will be very difficult. तो क्यों ऐसा सोचना कि what will happen next, what will be the next step? Just leave it aside. You do your work, practice and revise. That's it. Okay. Chalo, next question. A cycloidal gear tooth profile consists of only cycloidal, only hypoid, cycloidal and epicycloid, hypocycloid and epicycloid. Is a question which was asked in engineering service, in your HPCL also. I think last year this question was asked, and HAL also. तीनों exam में this question was asked, and we can hope this kind of question being repeated. A, B, C or D? Rohit, hunting वाला question हो चुका है. This is the next question, I think. Okay. Yes. A, B, C or D? Correct. देखो, only one response. What about the other? देखो, cycloidal gear you might have heard about. There are two types of gear profile. One is involute, second is cycloidal. Involute, how we are getting involute profile? How we are getting involute profile? Can you tell me? For those who don't know how we are getting involute, first of all tell me that. Then we're going to cycloidal. How you are getting an involute profile? What we are doing, we'll be having a fixed circle. On fixed circle, the circle is fixed. And on this fixed circle, what we are doing, the straight line is rolling without slip. And this condition we call it as, or the locus of a point, the curve that we are getting, this is called as involute profile. We will be having a fixed, and this, what is the name of this fixed circle? Those who have studied gears or gears terminology, they might be knowing this circle is called as a base circle. This is the same circle that we are seeing in the for creating the involute profile. Coming to the cycloidal. Now basically cycloidal profile is when on a line, when a circle is rolling without slip. Okay, but cycloidal gear tooth is being basically made up of two profiles. Okay, fine, it is basically made up of two profiles. So let us say this is the curve. On a curve, the circle is rolling without slip. Okay, when the circle is rolling without slip, under the curve, this is called as hypocycloid. Okay, and when the circle is rolling without slip over the curve, we are getting epicycloid. Okay, fine. And to make a cycloidal gear teeth, we are using both the profile, and that is the reason cycloidal gear tooth are expensive. These are expensive gears. I hope so. These are some small points you can, from single question, we'll be trying to revise the entire syllabus. Okay, acha. Interference is occurring in which gears? Involute or cycloidal? Interference is occurring in which type of gear? Yes, it is occurring in involute. Cycloidal mein interference is not happening. That is the reason whenever we are actually working where no interference is required, we are implementing the concept, we are implementing the cycloidal gear teeth. But because of this expensive or costliness, we are only limited to limited applications. Okay, fine. We are actually using the cycloidal gear where cost is not the criteria, right? और एक एक गियर टीथ को बनाने के लिए वी हैव टू हैव टू प्रोफाइल्स शुड बी ज्वाइंड, हाइपोसाइक्लॉइड एंड एपिसाइक्लॉइड. ओके, क्लियर है? वेरी गुड, वेरी गुड. चलो नेक्स्ट क्वेश्चन ऑन द स्क्रीन, क्वेश्चन नंबर 5. Which of the following is correct statement regarding flywheel? Which of the following is the correct statement regarding flywheel? A flywheel influences the mean speed of the prime mover. The flywheel influences the variation of load demand of the prime mover. A flywheel influences the cyclic variation of the turning moment, and the flywheel influences the mean torque developed by the prime mover. Let us see who's going to give me the answer. देखते हैं सबसे पहले 4 students who was going to give me the answer. A, B, C or D. Correct answer, not the incorrect. Okay. Shreyash, yes. Yes. Quickly. Rohit, Pravalika, Kiran. A, B, C or D. Read the statement carefully. देखो इसमें slight confusion हो सकता है. You might be getting slight confusion, but if you try to read the options carefully, there is only one option correct. Which of the following states the correct explanation about the flywheel? A, B, C or D? Gaurav is saying option C. Okay, very good. Definitely, if you have seen that whenever you are solving any question from flywheel, what we are getting? We are getting a fluctuation of turning moment. If you try to remember, whenever we are solving any question of flywheel, we are having T theta diagram. Okay, we are having this fluctuation of torque, and in order to nullify that fluctuation torque, we are having a mean torque, and this mean torque is being created or being we are getting this mean torque from the flywheel by using this flywheel, right? Now coming back to this, a flywheel influences the mean speed of the prime mover? Not at all. Variation of the load demand? No. Flywheel influence, this option B is for governor. Okay, it's not for flywheel. Flywheel influences the cycle variation of the turning moment? Definitely we are talking about that. Flywheel, wherever there is a fluctuation of turning moment, that is being regulated by the flywheel. The torque, the variation of the torque is being regulated by the flywheel. That is the statement. Option C is the correct answer. Okay, not A, not D. D तो हो ही नहीं सकता. It won't be influencing the mean torque. Influencing mean torque means the prime mover is giving me mean torque and flywheel is trying to alter the mean torque. But the mean torque को change करके it is creating cyclic. It is not possible. Influences का मतलब, let's say I'm influencing you to study every day 3 to 4 hours practice session. Okay, that means you are having some initial conditions and you are trying to influence that. Okay, so you are trying to influence the cyclic variation of the turning moment to convert into a constant turning moment. Clear? Option C. Very good. Chaliye, next question, question number 6. What type of progression will be followed by the amplitude of free oscillation with Coulomb's damping? Okay, let's see. Quick answers. Which type of progression will be followed by the amplitude of free oscillation with the Coulomb's damping? Harmonic, arithmetic, logarithmic, exponential. Arithmetic, logarithmic, exponential or harmonic? Okay, tell me, in Coulomb's damping, do we have any vibration? Do we have vibration in Coulomb's damping? If yes, then there is only one answer. If there is no vibration, then we have to go for either B, C or D. Quickly, wherever there is a vibration present in the system, always we will be having an harmonic motion. Yes, wherever there is a we can say damping present, that too under damped system, definitely we can say there is an harmonic system, right? So option A, we got a simple harmonic motion. Option A. If you remember in Coulomb's damping, Coulomb damping means you are having under damped system. Zeta is less than 1. Okay. If you remember, this is the type of oscillation being occurred. Something like this. This is an example of an under damped system. We are having a simple harmonic motion. About the mean value, the amplitude is changing. Option A. Very good. Acha, tell me if this would have been over damped or under damped. Then, this would have been over damped or critically damped. What would be the answer? If this would have been an over damped or critically damped, then your answer would be logarithmic. Remember, if you talk about the over damped and under damped, right? here the graph is something like this. है ना? Graph is something. This is your quick response. This is your critically timed. This is your over damped. Right? है ना? Logarithmic decrease of the amplitude. There is no fluctuations happening. Exactly. Very good. Very good. Correct answer. Option A is correct. Okay. Next question. Question number 7. What causes the variation in the tractive effort of the engine? Very easy. What is the reason for the tractive force in or fluctuation of the tractive force in the engine? Unbalanced portion of primary force along the line of stroke, unbalanced force of the primary force perpendicular to line of stroke, secondary force, or both primary or secondary unbalanced force. What is the prime reason for tractive force or traction, variation of the tractive force to happen in an engine? Variation of traction, variation of tractive force. Remember, अरे यार देखो, don't give me the wrong answers, because this is in your paid classes. I think it's not being run, but at least I have taught you last year this particular topic of balancing. If it is not clear, I'll be definitely taking the same segment again on the YouTube, but I want to have the complete clarity. Definitely. Very good, Manthan, absolutely correct. It is because of the primary unbalanced force, है ना? There are three effects. If you see the partial, if I say the partial balancing of primary unbalanced force, what are the effects? Okay, let's keep aside this question. First of all, tell me what are the effects of partial balancing of primary unbalanced force. Can you tell me? There are three effects. One is the variation of the tractive force. Variation of tractive force. Second effect will be the variation in swaying couple. Remember? And third one is your hammer blow. याद आ गया? अच्छा, tell me one thing. Variation of the tractive force and variation of the swaying couple is due to what? Which reason? Primary unbalanced force, that is okay, but along the line of stroke or perpendicular to line of stroke? It is because of the unbalanced force along the line of stroke. Along the line of stroke. But hammer blow is basically due to the primary unbalanced force perpendicular to line of stroke. Okay, so option A is correct. Option B is for hammer blow. Okay, and we are never ever bothered about the secondary unbalanced force. The reason being, what's the reason why we are not concentrating on secondary unbalanced force? Anyone who can tell me why we are not bothered about secondary unbalanced force? The reason being, it is having a very less magnitude. You might have heard about this. The primary unbalanced force is very, very higher than that of the secondary unbalanced force. And that is the reason we always try to concentrate to eliminate the primary rather than eliminating the secondary. If primary is being eliminated, we can say, okay, my majority of the problem is being resolved. Now let's work on the secondary. Okay, clear? Option A is the correct answer. Very good. Next question on the screen, question number 8. Very easy, very important. The logarithmic decrement of the damped single degree of freedom is delta if the stiffness of the spring is being doubled. Okay, so K2 is equal to 2 times of K, and mass is being halved, M2 is equal to M by 2, then what is the value of new logarithmic decrement? Delta by 4, delta by 2, delta, or 2 delta? Okay. Right. So are we having any formulation between the logarithmic decrement and the and your we can say zeta value? We are having one very easy formulation. So delta is equal to 2 pi zeta upon under root of 1 minus zeta square. है ना? So if I'm able to check what variation is happening in zeta, I can automatically say the logarithmic decrement variation. Okay, so what is zeta? Zeta is equal to C by 2 root K into M, right? Let us calculate the value of zeta 2. Zeta 2 is equal to, C is not changing, divided by 2 under root of 2K into M by 2. So this is nothing but C by 2 root K into M, and that is nothing but equal to 1. So if your zeta value is not changing, can we say delta value will be changing? No. So delta 2 is equal to delta 1, that is option C. Okay, option C. Is this clear? Understood? Because logarithmic decrement depends on only one parameter, that is your we can say damping ratio. Okay, it depends on only one parameter, that is damping ratio, and damping ratio we know the formulation C upon 2 root k C divided by 2 root k into m. So by that formulation we are checking, and the zeta value is not changing. If zeta value is not changing, so we can directly say the value of delta is also not changing. Clear, eh? Option C, everyone, an easy one, easy question, right? Okay, can we proceed to the next one? Question number 9, everyone. Chalo, next question, Baba. Next question, 9. If a planar mechanism with 6 links and 7 lower pairs, each lower pair is having 1 degree of freedom, then the degree of freedom of mechanism is, what is the degree of freedom of this mechanism? It is having 6 links and 7 lower pairs, right? Definitely they are saying lower pair means each is having the single degree of freedom, right? What is the value of F? There is no higher pair. Simple straightforward question. F is equal to 3n minus 1 minus 2j minus h. So 3 into 5 minus 2 into 7. So this is 15 minus 14, that is 1. This is option A. So this is an example of what? This is an example of a kinematic chain. This is an example of a kinematic chain. Kinematic chain, right? Yes or no? Or if one of the link is being fixed in the kinematic chain, that is called a mechanism. उसी को बोलते हैं mechanism. Clear? All right. Can we go to the next question? All set. Next question, number 10th on the screen. Almost we are coming to a halfway. For a 4-bar mechanism, planar mechanism, the links of the length are as follows. AB is equal to 90, BC equal to 40, CD is equal to 50, and AD is equal to 70. You have to tell me which of the link need to be fixed in order to get a crank mechanism. That means double crank mechanism. Basically, they are saying a double crank mechanism. Quickly, which of the link need to be fixed in order to get a double crank mechanism? Can we go through 1 degree of freedom in question is given? Actually what happens is sometimes they are tricking with the statements. Like in this case they are saying, even they are saying mechanism is nothing but degree of freedom is equal to 1. For a 2D planar linkage, if you are saying it is a mechanism, that is by default means as it is a single degree of freedom, right? But they are saying that this 1 degree of freedom is basically of each of the lower pairs. Okay, they are talking about that DOF of individual lower pairs, right? Okay, chalo, next. A very easy question. Okay, Manthan is saying option B. Anyone else? You have to go for double crank mechanism. बहुत easy question है guys. बहुत easy question है. A, B, C or D. Let me draw the diagram. A, B, C or D. This is A, B, C, D. AB is equal to 90. BC is equal to 40. CD is equal to 50 and AD is equal to 70. Yes, all of you are going with option B. Pakka, can we lock? Can we lock that option B, everyone? 100% correct or not? Okay. Tell me one thing. Is the Grashof law satisfied or not? Tell me one thing. Yeah, Grashof law satisfied hai. Which is the shortest link? This is the shortest link. Which is the longest link? This is the longest link. So this is your longest, this is the shortest. The shortest plus longest is equal to 90 plus 40, that is equal to 130, right? Good evening Jay, good evening. And length of the other two, P plus Q is equal to 50 plus 70, that is equal to 120. क्या Grashof law satisfied है क्या? क्या Grashof law satisfied है क्या? No, it is not satisfied. So if the Grashof law is not satisfied, you fix any link, what will be getting? If Grashof law is not satisfied, you fix any link, even the shortest link, then you always land up with only one mechanism, that is your double rocker mechanism. We can see S plus L is greater than P plus Q, that is your Grashof is not satisfied. Grashof law not satisfied. If Grashof law is not satisfied, you fix any link, you always get what? Double rocker mechanism. Double rocker mechanism. Option D is the correct answer. Option D, very good, Jay, very good. I hope so. In the lines, many of the students are giving me the wrong answer. I hope so you are realizing the mistake. Realization of the mistake is more important rather than giving the correct answer in the session. Okay, rather than giving the correct answer, it's okay, that is definitely a good point, but definitely if you are giving some wrong answer, you have to learn from that. All good? Chalo, next question. Question 11. Piston reciprocating inside a cylinder is an example of completely constrained, incompletely constrained, successfully constrained motion. Okay, very easy. A piston reciprocating inside a cylinder is an example of an completely constrained, incompletely constrained, successfully constrained, or which one? So we are having, this is the piston, okay, this is the connecting rod, this is the crank, right? So we are having this to be fixed. Okay, now if let us suppose agar ye connecting rod was not present, then piston could have a rotational as well as a translatory motion. If there is no connecting rod being attached, so piston can have both motions, you can have translatory as well as rotational, but because of the inclusion of this connecting rod, this rotation part is being eliminated. So can we say now it is restricted to reciprocate, it cannot rotate. So this is an example of a successfully constrained motions. Only option C, only option 3 is the correct answer. Clear? Only option C is the correct answer. Is this clear or not? Yes or no? Yes, मजा आ रहा है? All good? Enjoying the session? Enjoy कर रहे हैं तो please do like the session, guys, है ना? And this is the level of question in any PSU. This is the level of question that you are having in any PSU. You pick up last 10 years or 5 years of paper. This level of question, guys. तभी तो cutoff is this cutoff of these PSU papers are too high. The reason being the paper is very easy, है ना? चलो next question number 12. In an Oldham's coupling, the maximum velocity of the sliding is given 0.25 meter per second. The driving shaft revolves at 180 rpm. What is the distance between the two parallel shafts? A simple question from Oldham's coupling, double slider mechanism. अच्छा बताइए how you are getting Oldham's coupling? In double slider, which link need to be fixed? Quickly, which link need to be fixed in order to get a double slider? अरे बहुत easy question. To get Oldham's coupling, which of the link should be fixed? Connecting link, slider, या slotted plate. There are 3 different links we are having. Okay, we are having 2 sliders, we are having 1 slotted plate and 1 connecting link. So Oldham coupling, how we are getting? We are getting this by fixing the connecting link, fixing the connecting link. Yes, right? Okay, now come back to the question. They are saying that what is the distance between the shafts? So we know that V maximum is equal to the distance between the shaft into omega. Perfect. Very good, very good. So, अरे लिखने के बाद क्यों बोलते हो? Try to respond after I'm before I'm writing the answer. Okay, very good. I think there is a delay. Is there any delay that I am asking the question and you are responding after some point of time? Sir, is there any negative marks? Yes, majority of the paper में होता है. We do have, or last year it was not there, but this year it is. They have stated that it will be having negative marking. ISRO में तो है भाई, है ना? Fine. So here we are having, this is distance between the, let us say this is r, this is omega, that is V max. What's the value? V max is 0.25, omega is 2 pi into n by 60, that is 0.25 by 6 pi, है ना? This is in meter. You can say this is 250 by 6 pi mm. This is the distance that we are having. So somewhere around, if you try to divide by 18, so divide, this is 4 by 4 1. Are we getting 13 point something? Yes. Are we getting 13.26? Very good, Manthan. Option C, 13.26. Right, you divide it. You got 250 divided by 6, so 41 divided by 3, approximately 13 point something, है ना? देखो, without calculator you have to do the calculation. Do not use calculator, please. PSU में this has to be, because we are so much habituated in using the small calculation के लिए we are using calculator. I will recommend you, even if you are preparing for GATE also, if whenever there are small calculations, do not use calculators for that. Okay, chalo, option C is correct answer. Let's go for the next one. Question number 13. In case of 4 link mechanism AB, BC, CD and AD, if CD is fixed with the mechanism we are getting, see the Grashof law, please do check, because sometimes majority of the examination they will trick you. They will be fixing the shortest link. They'll be asking you whether we are getting double rocker or crank rocker or double crank. Okay, so please try to check whether the Grashof law is satisfied. Then only we can go for that. Okay, then perfect. I think in ISRO there was no. ISRO में तो है. ISRO में तो है. HAL में it's not there. तो ठीक है, अच्छी बात है यार. ISRO में there is a negative marking. Okay, and that simply means you do not have to leave a single question unmarked. है ना? That simply stated, it is directly indicating one thing: 100% attempt should be there. At the end, try to fill up all the options we are having, because you never know, you can get some 1 or 2 bonus question. है ना Jay? Okay, A, B, C or D. J is saying B, Manthan is saying A. अरे भाई, okay, let's see what is the A, B, C or D. AB is 3, BC is 4, CD is 8 and AD is 6. We are fixing CD. Okay, so this is shortest. This is longest. So S plus L is equal to 3 plus 8, that is 11. P plus Q, that is equal to 6 plus 4, that is 10. Again, the Grashof law is not satisfied. Grashof law not satisfied. Arey, Grashof not satisfied, you should be very happy. Whenever you are getting Grashof law not satisfied, you should be very happy, because you will be getting double rocker. देखो, last year there was no negative, but this year हुआ है, तो definitely you can expect easy question, right? And definitely the cutoff will be slightly on the lower side. हो सकता है lower हो, है ना? You never know, because it depends upon the performance. It's a relative performance. If majority are performing very well, so automatically that cutoff will be increasing, right? Okay, very good. Option B is the correct answer. Question number 14th. Okay, arey yaar, this is an easy question. The instantaneous center of sphere undergoing pure rolling on a curved surface lies at infinity, at the center of the sphere, at the center of the curved surface, at the point of contact of the sphere and the surface. Okay, so we are having a curved surface over which a sphere is rolling. Where will be the eye center located? इससे easy question you cannot expect in the examination. इससे ज़्यादा easy question you cannot expect. And I want everyone to be responding correctly, right? Okay, option D is saying, J and Negi is saying option D. What about the other students? इससे easy question नहीं आ सकता guys. Perfect, option D is the correct answer. Whenever you are having a pure rolling condition, right? Rolling जब भी देखो, try to understand the eye center is always at the point of contact. Okay, wherever we are having the concept of rolling, even if you are rolling on a curved surface or a straight line, your eye center will be located at the point of contact. But this is not happening with the sliding. Let us suppose if you are having a sliding. If you are having a sliding, where will be the eye center located? Tell me. A body sliding on a curve, on a straight line, and a body sliding on a curved surface. Do we have same eye center? Eye center will be located in case number 1. Where will the eye center located? Anyone? दोनों में अलग होता है. देखो, same motion is happening. This here also we are having sliding motion. Here also we are having sliding motion in both straight and the curved surface. In straight, the eye center will be at infinity. है ना? The eye center will be at infinity. Yes, but whenever a body is sliding on a curved surface, its eye center will be located at the center of curvature. Okay, it is not at infinity. Okay, it will be at the center of curvature. Is this clear? Exactly, because rolling doesn't depend upon what kind of surface we are having, even a straight or a curved surface, but sliding way it basically depends. In sliding we do have the dependency of the surface profile, but in rolling it is not having any dependency. All right, all clear? Okay, next question on the screen. PQRS is the 4-bar mechanism as shown below, where PQRS is being given. The length is given, PS is fixed, and omega PQ is 5 radian per second. The velocity of point R. What is the velocity at point R? Let us suppose this is having this as omega and this is also omega. What is the velocity at point R? Right. And there is one thing missing over here. These two are perpendicular. Okay. These two are perpendicular. Right. Okay, fine. So tell me what is the velocity. Now, whenever this is a special case, whenever in a 4-bar mechanism, if the input and output link both are parallel to each other and perpendicular to the base, then definitely we can say the VQ will be equal to VR. VQ equal to VR, and they have given you omega PQ, so we can calculate very easily. है ना? चलो बताइए what's the answer, A, B, C or D? A simple question. Sir, VQ will be equal to the distance PQ into omega. Right, so this is distance is 300 or 0.3 into 5, that is 1.5 meter per second, and that is also equal to the velocity at point R. Right, so we are getting this to be option B the correct answer. D kaise yaar, won't be having any D. B option, Jay Manthan, correct, very good. 5 into PQ length is 300 na, very good. Chali, perfect. Next question on the screen, question number 16. According to Kennedy's theorem, the 3 eye centers of the 3 links mechanism having a relative motion between the links lie on. If there are some links, right, and they are having some relative motion between them, then the eye center will located in a triangle, in a parabola, in a straight line or a circle. Hana, I told you. Exactly, option D. हाँ तो HAL में ना, HAL में नहीं है, तो वही तो बोला, ISRO में there is there. चलो, option D. Yes, it's quite easy. Let us suppose I'm having a 4-bar mechanism. If I'm having a 4-bar mechanism, right? So this is a link 1, link 2, link 3, link 4, I12, I23, I34, I14, right? So let us say this is your this is I13 only, right? So you take 1, 2 and 3. So I12, I23 and I13, right? So all these 3 will be locating in the straight line if there is a relative motion. So 1, 2, 2, 3 and 1, 3. Yes. Okay, fine, right? So option D is the correct answer. Question number 17 on the screen. Will they ask only current affairs in the general awareness section? No, current affairs say majority आता है. It's not like this. It will be only having current affairs. GA में we can have factual based question also. We can get some factual based question also, right? Not only about current affairs. Okay, Ritvik. Okay, next question. The 2 gears in mesh are having a constant velocity ratio. The module is 2 mm. What will be the circular pitch? What will be the circular pitch? What will be the circular pitch? Quickly, PC. Sir, PC is equal to pi d by t. Not the diameter given and not the number of teeth. But yes, there is given one thing, pi into m. Module is 2. So 2 pi is the answer, option B. There is no doubt in this option B. Let's go for the next one. Is this clear, everyone? So the next question. 18th, the module of a gear having 10 number of teeth is 5 mm, meshing with a gear 2 having 20 number of teeth. So this is your gear number 1. This is your gear number 2. Right? Both are meshing. ठीक है, आपको लग रहा होगा mesh नहीं कर रहा, but mesh कर रहा है. This is T2, this is T1, this is 10, this is 20. And they are given the module value is equal to 5 mm. They are saying what is the distance between the central distance between the 2 gears. 30, 40, 50, 75. What is this distance? Let's say this is C. What will be this distance? Anyone? 30, 40, 50, 75. A simple question. My central distance is equal to R1 plus R2. Okay. Or I can say M is equal to D by T. Right. Fine. So R is equal to your M into T by 2. So it will be M into by 2 T1 plus T2. Chalo, place it and tell me. Place it and tell me. Yes. No, the questions from 15th onwards are previous year HAL. Question number 15th onwards are previous year HAL questions. From 15th onward, before 15 was practice, but 15 onwards we are having the HAL PYQ. So you can imagine the level of questions. ऑप्शन डी परफेक्ट 75 है ना, ऑप्शन डी 75 एवरीवन, very good. Mega will be covered or whole mechanical syllabus will be covered because the few major topics. No, basically I'm not only going for HAL, I'm planning for HAL, ISRO and HPCL. All the three examinations will be covered. The practice that we are going on, I'm keeping in mind that all the three examinations will be covered in one go. Right? The name is HAL, but back of the mind, ISRO, HAL and HPCL, both, all the three exams will be covered. Right? Option D 75 is the correct answer. Right? Okay. 19th question, a very easy one. The equation of vibration of the system is a very easy question. देखो यार ऋत्विक, every session student do ask me about ISRO. देखो last year trend के हिसाब से it should have, they must have given the date, but still they have not given. Might be some internal reasons which we don't know, but at least what we can do is, as they have given the notification, they will definitely gonna conduct the exam. So you should not be worried about when the examination will be happening. You should be worried about, is the revision going on appropriately, is my practice going appropriately, is my mock test, I'm giving the mock test appropriately. That should be my concern rather than having the release of the date. Chalo, no problem Ratvik, but at least देखो, whenever you're having the doubts, you should be clarified. That could be technical or non-technical, right? Chalo, come back to this. Tell me the answer for this one. 3.5. Okay. 3, 7.5 or C. A, B, C or D. What is the answer? Shay is saying 3.5. What of the rest? देखो, when we are applying the brains, then only it will be working. कोई conceptual question आता है, then brains are working, then only the brains will become sharpened, right? So definitely whenever you are having any concept or any doubt, try to clarify then and there itself. Do not wait for any other day. Okay. चलो next बताइए, what's the answer? Option B, D. Okay. Now we are having some changes in the options. Option B is the correct answer, guys. Try to see the units. They are asking in hertz. They're not asking in radian per second. So if I say x double dot plus 49 by 4 pi square x equal to 0, compare with the standard equation omega n square x equal to 0, omega n is equal to 7 by 2 pi or 3.5 pi radian per second. But here they are asking about what? They are asking about hertz. So frequency is equal to omega n by 2 pi, right? So this will be 3.5 by 2 pi get cancelled out. This is 1.75 hertz. Okay, ये common mistake होता है. This is the common mistake students are committing in a hurry when they see an option which and that is exactly matching with your answer. So we are habituated कि हम लोग बहुत ज़्यादा खुश हो जाते हैं, है ना? It is a story of every aspirant, any examination. Whenever we are seeing in the options the same value as that we have calculated, बहुत मजा आ जाता है. The confidence is at peak. But try to invest 5 more seconds and see whether we are responding appropriately. क्या units में कोई इधर तो नहीं है ना? That should be make sure. Okay, fine. चलो next question. 20th question. 20th question. Quickly. 1 second, guys. Exactly. 1 second. Quickly, tell me the answer. Okay. Now I think we can continue to the session. वैसे भी last question पहुंच गया था. Almost we are at the last problem. हाँ, चलिए, perfect. There was some voltage fluctuation. My voltage also get excited whenever we are getting this. Okay, the answer for this is option A, B, C or D. Option A, B, C or D. Yes, everyone. Certainly the voltage dropped. तो इसकी वजह से that is happening. I hope so now that is being rectified. But वो voltage बहुत low है. It won't be able to take that. Okay. For vibration system, the equation of motion is. Okay, they're asking the omega d value. omega d value they're asking. So we can say this is plus 2 zeta omega n x dot plus omega n square x equal to 0. So from here omega n is equal to 5 radian per second. And we know that omega d is always less than that of omega n, so we can eliminate option C. Option C won't be possible. Okay, so what is omega d? That is equal to under root of 1 minus zeta square into omega n. So under root of 1 minus zeta, what will be the value? 2 zeta into omega n is equal to 8. So zeta is equal to 8 divided by 2 into 5 or 0.8. Okay, so 1 minus 0.8 square into 5. So this is 0.64, that is under root of 0.36 into 5, that is 0.6 into 5, that is equal to option D. Option, yes, option D is the correct answer, right? Okay, I think यार ये problem resolve नहीं हुआ है ना? Yes, option D is the correct answer. 3 radian per second. 0.6 into 5. Next question. Let's 21st. Second last question hai. Then we'll be winding up the session. The gyroscopic effect will be 0 in case of. Very easy question. Gyroscopic effect 0 किस case में होगा? Steering during the ship turns left, steering ship turns right, ship during pitching and ship during rolling. A, B, C or D. When will be the gyroscopic effect will be 0? देखो, we are studying in ships the steering towards left, steering towards right, the gyroscopic effect is coming. But whenever the rotational axis is having the same axis that of the turning motion, so that we can say, अगर ये आपका है rolling, है ना? Rolling में क्या होता है? The ship is moving like this, ठीक है? And here, what is happening? The axis of rotation is not changing. Agar axis of rotation is not changing, we can say d theta by dt is tending to 0. If d theta by dt is tending to 0, that simply means your omega p will be equal to 0. Omega p will be tending to 0. That means it is in the option D. Okay, very good, very good. Option D is the correct answer. Last question on the screen. An aeroplane is making a right turn. What is the gyroscopic effect if the air screw rotates clockwise when you view it from the rear? So we are having an aeroplane, right? We are having an aeroplane and your rotor, you are seeing from the rear view and it is rotating clockwise. Okay. If it's taking a right turn, what will be the effect? If it's taking a right turn, what will affect? So if let's say this is the aeroplane, this is the rear view, it is rotating clockwise, right hand thumb rule, it is turning towards right. Okay, this is the active, we have to go for reactive. So this is the reactive, that means the front portion will try to move downward and the tail will try to move upward. That means there is a raise in tail and the dip in nose. Option B is the correct answer. Okay, option B is the correct answer. Is this clear, everyone? So last 3 question में थोड़ा सा problem हुआ. I think that was the case, and उससे पहले तो I think all was it. So these were the all questions for the PSU examination, that is HAL, HPCL, SRO examination के लिए हमने देखा. And Rakesh sir will be coming up live on 6th of September at 7:30 and he'll be telling about the mantra to crack GATE exam, scoring 13 out of 13 in mathematics. बहुत बड़ा session है यार, क्योंकि 13 out of 13 is a very good score in mathematics. Okay, and for registering to this workshop, you can there's a link in the description, you can do join that, and there's wherever you require any resources, there is a, we can say, treasure of resources in the link in the description where you can download the free PDF for the preparation, right? Okay, चलिए. So and about the vision gate, already gate का course चल रहा है. Those who are not yet started, I would say अब आपको strategic approach होना चाहिए. For that we are having a vision gate, a complete study plan, right? Sunday का fun and Super Saturday is going on every Sunday and Saturday. I hope so. Is Sunday I have taken a session on CVT. यार mechanical students हो, सभी लोग उसको देखो and do let me know whether you liked or not. I took a session on CVT transmission, how the CVT is working. Try to see that and do let me know your feedback. Okay, right? So thank you, bye bye, take care and stay safe, and let's meet in the next section tomorrow at 7 p.m. we'll be having the next subject every day. Okay, Monday to Friday on YouTube we'll be having the practice session. Okay, practice session for HAL, ISRO, and HPCL, right? Okay, and for GATE, I am taking session at 4 p.m. on our app. Okay, आप उसमें भी जुड़ सकते हैं. That is also same Monday to Friday. Monday to Friday, right? So I'll be sharing this PDF on the Telegram channel. और आज मैंने जो ऐप में क्लास लिया था, I have given a homework question. Let us see who's gonna give me the answer for that. What you have to do is you solve that question and take the pic of that and send it to the Telegram channel. In the next class, I'll be seeing who has given me the answer. Okay, fine. Chaliye. Thank you guys. Bye bye. Take care. Stay safe and enjoy your day with BYJU'S Exam Prep. Thank you. Bye bye.